Hi everyone, welcome to the guided notes video for notes number 7, where we are talking about roots of polynomial equations. You already know something about x squared plus, let's say, 6x plus 7, right? You could factor that, and you could tell me that the two factors of this are plus 7, oops, I think I need to fix this. Let's see, plus 7, this should be plus 8, plus 1. And so this function has roots where x equals -1 and x equals -7, okay? You could tell me that this function has two real zeros, right? It has two roots. That's not a coincidence. That's because of that power right there. It's going to have two roots because it's a quadratic. That means it's going to cross the x-axis, cross or touch the x-axis twice, okay? Because it's a parabola, you also know that it's a situation where it can look like this, -1 and -7, or in a different, in a case if it just touched, then it would just touch once. Let's say it would touch once at +2. Okay, so we can have touching roots or we can have crossing roots. This becomes important because it determines the kind of factors that we have. So we're going to connect the algebra to the graph down here as we work through a couple of examples. I'm talking about polynomial functions, so that's anything that has multiple terms in it. So I'd like you to consider something. I'd like you to think about a polynomial that has only, let's just use 3 just to keep it simple, that has only 3 as zeros. Okay, so a polynomial that crosses the x-axis at +3 and only +3. We could have a couple situations, right? We could have a function that looks like this. You can think of the parent function of that as x cubed, right? Or we could have a function, let's see, in a different color, or we could have a function that looks like this, where maybe it just touches and turns around. Okay, in which case that parent function is x squared. In the case of x squared, both roots would be where x equals +3. And in the case of the polynomial, or the x cubed function, I would have 3 roots at x equals 3. What I'm getting at here is this new term called multiplicity, right? This function has a multiplicity of 3 because it crosses the x-axis. In all 3 roots are where x equals 3. This function in red has multiplicity of 2 because both roots occur where x equals 3. All right, we are moving on. I'm actually going to pause this and have you, actually I think we have I'll pause this and then we'll get into part 2. In the meantime, I'd like you to think about a couple of things. I'd like you to find a polynomial that has a leading coefficient of 1 with such zeros. So come up with an example where all of the roots are at x equals 3. So see if you can come up with an equation, f of x equals, where at least 2 roots cross the x-axis at x equals 3. For example, x equals this, maybe f of x equals this. Okay, then I'd like you to find a polynomial with integer coefficients that has such zeros. So a leading coefficient of 1, and then a polynomial with integer coefficients that has these zeros. So then come down and simplify this polynomial. Write it for me in standard form, whatever you've chosen in standard form. Okay, I will see you in the next video.